If you're like me and have enough or trying to align your piece of work with the X and Y axis of your xTool S1, I created a jig to help you on that. This simple jig allows to align the honeycomb directly with the processing surface of the xTool S1 and allows you to lock in place your material directly aligned with the axis. Let me show you how to create one for you. The major issue with the xTool S1 is that the honeycomb is not actually fixed into position into the machine. It's a great thing if you're trying to process a larger part, but the problem is that it does not align automatically with the processing area of the laser of the machine. Therefore, you always have to try to find a position where you try to maximize the operation of your piece of wood, but also if you don't have any reference, you have to frame all the time your part to make it actually align with the X and Y axis of the machine to be able to maximize your cutting area. One of the issues as well is that you cannot simply put it on left or right of the machine, because for some reason my honeycomb is not square. So it's actually, if I put it completely aligned on the side, this is not aligned with the x-axis. So if I move it, you can see that it's not moving correctly along the path of this. So it has a bit of an angle. So making these two is actually the reason why I wanted to have a jig, to be able to align automatically when I need to take off the honeycomb and clean it, or removing materials or anything like that, to be able to place it directly. And the second is I don't need to try to align the material with the X and Y axis. I just simply lock it in place and off you go. I know exactly where it is. I can process it directly. So the first step to determine where is the processing area of the xTool S1 against the frame is simply to put a couple of lines on each corner and to actually put a piece of wood against the frames like I've shown, and you just engrave or score the material, and you will have two lines on each side. So you do it, for example, on the left side first and on the right side. When that is done, you can just design the part like I've done. So in my case, it's 93 millimeters from the score line to the side of the frame. And again, here it depends if you have the height extender or not. So here it's a case of the height extender, and it's actually 34 millimeters from the front. I put 220 millimeters and 240 millimeters. You will see later, because I wanted to be able to have all the parts in one 12 inches by 12 inches or 300 millimeters by 300 millimeters piece of wood. So that's a determination that I got. For the bottom left, so there's two parts, the top one, which is like this, and the bottom, it's the part which is going to be glued at the bottom to ensure that it's holding in place. And we had 34 millimeters, so I had to start my supercomputer, like NASA style. And actually 34 minus 22, it's actually 12. So that's what it told me. So I got all this, and the same thing after placing the honeycomb correctly. I measured that it was 47 millimeters, and I just changed slightly the dimensions to also fit in one slide. Now, looking at the right side, it's the same principle. You measure the two dimensions left of the score lines, and I got 24 millimeters and 34 millimeters again. So it's just a simple part cut like this. Again, the dimensions are just there. You're going to see after. So I can actually have all the parts in one 12 by 12 sheets, so it's easier to make. So after exporting the shapes that I created in Fusion 360, I put everything in one piece of 6 millimeter plywood sheet, 12 by 12. And that's why the dimensions were as they were in the design, to be able to fit everything. I also put a scale on this. So I have roughly a centimeter scale on both of the elements, and this is the lower left, and this is the pieces that you can glue at the bottom and at the top of the part, so it actually sits correctly against the frame and against the honeycomb. I decided to put a little logo here to make it pretty cool, and I will share the file if somebody needs a file to create the same. I will share the files. Just keep in mind this is only for if you have the elevation, the extender, height extender of the S1, and also it's 6 millimeters. So your machine may be slightly different. So I would definitely recommend that you actually measure it. Normally it should be exactly the same because the machine should be the same, but just in case, definitely do the little score marking on a piece of scrap wood so you have the same dimensions. And if they are matching, mind you can actually just take the file and cut it, and it's pretty cool. When you have cut the part, this is, for example, the 6 millimeter plywood. The little blocks are coming at the front to sit at the front of the frame, and the bottom one are simply to position the honeycomb. So what you do, and you have both sides, you have the two parts that are showed on the CAD, and you can glue the two little parts at the front. And the way it works is that you take the left side, you position it against your frame, and you take the front, but it won't work. So what you do is you first push on the right side, so this actually fits, and when it's actually pushed on the right side, you just push at the front, and it automatically aligns with the x-axis and y-axis of the machine, and actually the honeycomb. So when you want to process something, take a piece of wood, boom, you're aligned with the axis and the coordinates of the machine. And this is how I did jig. I hope you like this video. I will be putting the file to cut the thing in one sheet, most probably on the website, and I'll put the link into the description. And if you have any issues or anything like that, just don't hesitate to contact me. And you can write in a comment. If you find another way of doing that, I would like to know that. I'm always good for good ideas. Thank you very much for watching, and see you in the next video.